And once again, this is our third try. It's 28th Knowledge Seekers Workshop. We'll take it through and go to the Spaceship Institute and talk to Mr. Kesh of the Kesh Foundation and the Knowledge Seekers from the Spaceship Institute. Okay, if you want to try it there, Mr. Kesh. Sorry for the interruptions.
Good morning for the third time. A good day, wherever you are, as we always say. We tried for a third time to see if still there is no echo and we can carry on. Repeating what we said, because you're recording again, that is that there is there are some people we announced or have been spoken internally with different members of the foundation around the world that we removed 5 reactors from their lab in the past 2 weeks. These are all the ceramics which John made due to the inherent, production problem with these ceramic cores. They interfere or they absorb or they reflect the fields which we produce in other cores, and they interfere with the working of the systems in the lab. So we remove these from one lab into another lab that they are not interfering with our system. And this process we had to take one reactor out of a set, a Starship star system. And so we have a vacancy for one reactor. As we discussed, we could build one reactor ourselves and make it the fourth one in that set. Or as we now teaching internationally and working internationally with a lot of people around the world, knowledge seekers around the world can offer the reactors they have, working reactors, or a reactor they built and they think it's not working, or they think we might be able to utilize it here. So Rick will put a notice up on the forum. This is not a competition. This is trying to work together in a collectively or collaborating in different ways. We will choose collectively which reactor as we see fit here in the center that it can, work with our other sets. And maybe 1 or 2 reactors we will request if you like to send to the foundation for it to be used, or you can bring it yourself. We don't accept any reactor which ends up at the front door, because it has to fit into the systems which we have here, and it has to be applicable that we can use it. So we'll have a look, and in the next week or 2 we announce which reactors we're going to take up. And if you want to bring it or send it to us, you can come here and connect it yourself, and we'll try to run a test and see what we can get from it, or how it can be added to the set. As I mentioned before, by bringing your reactor, it doesn't give you the right to stay here for a year or 2. As some people said, we can afford expenses. We have to have, first of all, the possibility of people who come here to stay, to pay for the tuition. And secondly, they can bring additional talent or information and knowledge into the foundation. If you have a reactor and you have the time and you want to be a knowledge seeker and bring your reactor, but your expertise at this moment are not something we can use, then we only love your reactor, not your expertise. But I'm sure everybody can collectively add to our knowledge in one way or another. But so we're looking for 1, possible 2 reactors. It can be as a backup that we don't need to build a second one to keep, and put it up on the forum. And within the next week or 2 we decide collectively which one suits our setting here, and we'll start bringing it in and setting it up. There are some parameters, like it has to be a 6 millimeter pipe feed. It has to be a revolving valve, which is one of the better ways to have it, that we can have a condition of it. If it's a double core, it'll be good. If it's a single core multi-layering, it's still the same. We are looking for different variety or a different option, or another new ideas into it. A copper coil or a steel core we have plastic cores we have here, but maybe you can suggest, or you have developed something which is slightly different than what we have. We have to be open-minded in respect to everything. So if you make a reactor of a coconut shell and it works, it still is as good as our copper-coated fancy reactors. But the coconut should just stand the highest speed and it doesn't crack. So we'll see how it goes and how we can develop this situation as international collaboration. We don't know. So we see what has to be. John says there'll be more holes in coconuts than in the ceramic. So we'll see what happens and how we can do this thing. The other position which is at the moment going with us is the situation with Africa and Ebola. We're still carrying on with our development, research and teaching, and hopefully Mr. Cash's sound has gotten worse. Maybe I'm getting old, that's why. Yeah, that's Arma. Yeah. So we are still carrying on with our work in Africa, and we have not received the data from the what do you call it? From the scientists. Managed to, they had to reproduce more material, and we'll see what comes up in that's the trials which are starting and going on there. We are still waiting for other developments. There's been a lot of situation in a way with foundation here. We're trying to add to the knowledge more than trying just to build things. I think Marco and John can add to what we've learned and what we are learning here in the center. And the whole structure is that they're in process of teaching and learning this week, came across the understanding that a lot of people do not appreciate and understand the process of the use of the GANs and nano materials and matter. And this needs a lot of what do you call it, simple understanding, in a way that Marco has spent more or less whole week building a new cell, which is, you see it on the, if I open the camera, this cell, he will explain what is done, how it works. By building these cells, we came across sort of gap in the knowledge, which trying to fill in. As you understand that these combination of the GANs and nanomaterials has created totally new opportunities in energy production. But at the same time, we have to understand the method that the energy is produced. The process is that you have the GANs, which you put in these containers. You see it in different color, small. We're still using the contactless containers. And the nanomaterial is that the energy from the GANs is transferred through the nano layers, which is put in there by the electrodes into the nano layer coating. And you have two options. If the current flow goes from the nano layer to the copper inside, in the inner sanctum of the wire, you get the transition from the plasma to matter, and you create the AC. But at the same time, if you have a second electrode which is not coated and is in the liquid, and your nano coated material, now the nano coating outside plays the DC. So the wire on its outer core leads in conjunction with another point to a DC, but in conjunction with this inner copper wire leads to DC. And one of the problems which a lot of you will observe, or most probably have seen, and what I've seen in a way disheartens you, there is something wrong. And that is, you say, I get no AC or I get no DC. I had an AC, but I don't have an AC now. I had AC before. There is nothing wrong in what you read. It's the lack of understanding of what you are doing, in a way, what you're leading to. Go back to the very first talks about the Gans and the Nano materials, and go back into the understanding of the working of the plasma and the teachings of the energy production. One thing which you most probably have forgotten is that I was explaining to Marco this morning again, that you are dealing with universal condition. You are dealing with a plasma condition. In the universe, in the reality, even with the structure of the soul of the man, very much the same as your plasma of the gas and your gas and your nanolayers. You take from environment what you need at the point of the need. You don't, it's the habit of the man to get as much as you can and collect that one day you might need it. This is the problem with your Gans and Nano layer coatings. If you connect your wires and you get a DC reading, and then you don't get an AC reading, and then you get a DC reading, AC reading, and don't get one. One was more, one was less. I was getting 1 volt before, now I get 0.2 volts now. Understand, first of all, the equipment you use, how much energy it takes, and where you are storing the energy, what is its capability and what it needs. So I was showing today to Marco this morning. He has made a beautiful set, and the battery is charged because John tried it for past couple of days in the same set. The battery wasn't getting charged. Marco has put it on for a couple of hours yesterday, and the battery is charged. And to him, he could not understand what is happening. This morning, I explained to him, I showed him, I said, touch the battery. The battery is not hot. The battery is normal room temperature. But your battery is fully charged. What does this mean? In electronics now, when you put a battery on the charger, when the battery gets charged, there is an electronic system that the miniature chip recognizes the battery is charged and it stops the current flow to the battery. In the Gans and Nano layers, your battery, when it's charged, it doesn't need anymore, so it doesn't take anymore from the environment of the Gans or the Nano layers. You reach a point of balance. Balance between your AC and DC in your battery, the balance between AC and DC from the lines which you are feeding it. So when you reach balance, you have no need for extraction. As I said to Marco this morning, you put 1,000 batteries next to each other. Every one of them, once they reach point of charge balance for the battery, not in you, as you overcharge nowadays, and then after about 200-300 times charging the battery, it runs out of energy, or it gets reduced charge, you see, and the battery gets damaged. These batteries never get damaged because they charge themselves to the limit which they accept they can take. So you don't need the regulator to charge it, and then when you get to the maximum. The balance condition between the nano layers, the GaNs, and the battery content, what's in there as a charger, dictates that's the limit. And then the process stops. So if you put another battery next to it, it'll start charging the next battery. And then the next battery. And then if you recharge or use part of the first battery, when the system is going around, it comes back. It comes back to recharge to create balance. So you don't get overheating. You don't get heating up your batteries. You don't have the problems you have with the present charging. So the whole condition comes again in a schizophrenic mind. Try to understand what you're doing, the way you're working, what is the new option, what are the new facilities available in the world of science with the use of the GaNs and the gas and the nanolayers. This is something which I explained this week to the knowledge seekers here. I was out, I came back, and I had Marco and John sitting with a bag in front of them, and they were very happy. They went out shopping, what was it, transistors and capacitors and diodes, that, as you've seen last week, they charged the diodes and the capacitors were charged, and we could show that the energy from the nano layers or the GaNs containers can charge the capacitor. Now we're going to the next step of understanding. You are dealing with a new state of matter. You're dealing with the different dimension of the plasma according to what you have created. If you understand the structure of the plasma, if you understand the working of the plasma, if you understand the working between the plasma of a matter and the plasma of the GaNs and plasma of the nano layers, then you will understand you do not need any capacitors. You do not need the present matter resistors. You create your own storage batteries from your own GaNs material. What does this mean? Look at the structure of the CO2. Look at the structure of copper oxide. Look at the structure of other GaNs materials you produce. You go by a strength, by order of magnitude. You can create, absorb energy in the CO2 and use a copper oxide to use it, maybe as a storage, maybe as a resistor, maybe as a booster, maybe as a balancer. Nobody downloading anything from here unless you want us to disconnect the camera. Somebody in the background is downloading, maybe Armin or somebody. That has to stop. Nobody uploads anything because they have a distortion. So go back on understanding of What are the new options? Go back on understanding what is available new with a new understanding. You do not need the physical batteries like we show in the torch. You do not need the bridge to convert AC to DC. If you understand how Gans materials can be used as a storage, or how you can use nano layers as a storage, then you don't need any all these electrodes, what do you call it, diodes and the bridge and everything else, and all the capacitors and the rest of it. You can start developing new limitless storage systems, plasma batteries. But you have to understand how you do it. We came through the process of producing the whole steps. Now you understand there is a ACDC in the characteristic of your material. You will understand there is a ACDC within the plasmas too, of the GANs. So understand what you want to use and how you want to use it. As I always say, motors are the creation of man. There are no motors in the universe, and energy is stored, and we see them in different ways, even in the clouds. Understand the process. You have to understand, even look at the structure of the Gans state of matter on the upper layers of Saturn. Look at the structure. What structure has given the shape and what capacitor can be used. How you can organize your ganses in a shape form that the energy is not contained in the GANs, but within the environment of the GANs containers. What this means, if you can extend it, is, as you've seen in the pictures of the batteries with the GANs, which Marco and John and Arman have made in the last week or two, is you will find energies between the containers, not necessarily in the liquid itself. Because now the dimension, the extension of the knowledge is in the plasmatic condition. You confine your ganses in little containers and you put so many of them next to each other. But now, because you work with the GANs, you're not dealing with the battery anymore, that's what's in the battery. You can use the environment around your container to be able to absorb, to store, to define energy, and being able to get energy from it. So you have to make the tools to be able to reach that. You don't need to be in the liquid. You don't need to be in the GANs material. You don't need to be in the nano layers. Then you understand how to tap into the universal energy. Then you understand you don't need a battery to light up. You can allow the condition very much like as you have the solar lights at the moment. When the light slightly changes, the detector switches the light on. So you set the scene when you want the light. In so many ways, you have to start looking at interaction of gravitational magnetic fields beyond containment. But we had to go through the process slowly, that we understand step by step, and people around the Keshe Foundations understand it. Now we're going to the next stage. So start looking not to have a battery charge or rechargeable battery, or number of rechargeable batteries. Try to produce energy storing system out of the ganses or environment between the ganses. This is what I was explaining today or this week to the knowledge seekers. In a star formation, you have a reactor in the center and you have other 3 reactors in the boundary at the same height. The one in the center is usually in a higher position than the other 3 in the, what do you call it, the base level. Look at the structure. You have a pyramid. Top sits the center reactor, and the other 3 at the bottom create the center point as a pyramid. The knowledge of pyramid, which we see in so many ways in Egypt and other part of the world, was taught to man in the last contacts, in the last teachings, but man did not understand. So they tried to convey the message by building the pyramids. And a lot of people speak about the pyramids, they have this property, that property. Look at the star structure and look at the galaxy's structure, you see a lot of structure of pyramids, even between the star formations. Where does the energy of the pyramid sit? Where is the balance point? Where is the interaction point? The interaction point is not in the reactors. The interaction point of the 4 reactors sits somewhere underneath the main reactor, somewhere not very far from the top or in the middle. Because it goes back to the understanding of magnetic gravitational positioning. You have 3 reactors in the base, which they create gravitational magnetic positioning of themselves in respect to each other. Each one of them has to create gravitational magnetic positioning with the top reactor. And then the whole fields from all individually, collectively, have to find a balanced gravitational magnetic field, which is somewhere in the center of the structure of the pyramid. That point, the gravitational magnetic field in that point is the gravitational magnetic field strength which interacts with the Earth gravitational magnetic field, which leads to the lift or what do you call it, descent. Or the gravitational magnetic field which you create in that point in the center dictates your position in respect to your destination point. So, in so many places, in so many ways, understand what the structure as a gravitational magnetic field plasma brings as a knowledge, as an energy to you. Then by changing the gravitational magnetic field of one reactor, you change the position in respect to the other gravitational magnetic fields in the reactors, but because they're in balance, they show their interaction with their destination or with the position they have in respect to Earth. Then you can find out, you can see how the whole structure itself can repeat it in your Gans containers. If I was trying to teach this week to the knowledge seekers, we have 3 plates now with these, what do you call it, contact lens containers. I said to them, put it on 3 different plates, like a stacker, and move them. And then find out what energy they have. In reality, if you look at it, look at every container as one nano position. Then you understand, you see when the interaction and production of energy and positioning in nano layers, because each plate with, let's say, 10 or 15 or 20 containers of gases on it is different nano layers in respect to the one below. Then try not to measure the energy between the plates only, but try to see the energy between the gaps between the plates. And you find out you have much more energy stored in these gaps than in the containers of the gases. This is the new way to create unconditional, non-containable chambers of energy. In fact, you create your own nano layers, and then you decide by distancing it from each other, by positioning it or moving sideways or up or down, what energy you want to store in these capacitors of non-dimensional capacitors. Because now the boundary of your battery is your nano layers. Then change the content of each container from a CO2 to copper oxide. Change it to CH3. And then you find out you have different dimension, different battery structure. You have a three-dimensional, and as you move your electrodes, which you have to develop special electrodes to be able to measure the energies between nano layers or between your stacking system, you'll find out the true free energy is what you're looking for of the universe. Because in that gap, whatever is available in the universe is available in that non-conditional, non-structural, plasmatic, magnetic fields positioning of the gases, of the matters, of the plasmas. Then you can understand the whole structure. You can physically explain the working of the nano layers. You can physically explain the position and development of the new materials. The whole structure, the whole parameters of nano layers can be contained in literally in cells, impregnated cells layers. So you can produce in a very simple way your own nano layers, but built from ganses. And how you position them, you can stack. Then there is no limit. You want 10,000 megawatts, or you want 10 watts or 1 watt, depending on how much of it should be the current flow of the plasma and how much it should be the potential difference of the plasma. The potential difference, or your voltage, comes from the distance between the layers you create. And the current flow in your plasma comes according to the mixture of the gases you use. So now you create new three-dimensional plasma capacitors or batteries or energy storage of the magrav level. This is the next step for the knowledge seekers to start producing these systems. Then we don't need to go to the shop and buy capacitors and resistors and be happy sitting on the table. John is laughing his head off. You should have seen the grin on their face when I came back and Marco was sitting with a bag. I said, what's this? We went and did some shopping. We bought some capacitors. And in a way, this is what we are used to. Now it's the extension to the knowledge. You have the capacitors. You understand the gas is a plasma. This is what Arman is trying to do with the new reactors. This is why we are filling up the new reactors with the GANs. Today, tomorrow, the Italians will bring us back one of the reactors, which we can show you can transfer the energy from the gas in the reactor to the current, electric current flow. If we don't get it, it means we have not got the right equipment to tune to the magnetic field of the plasma, which is released inside the container by the plasma, or our system does not need the energy. Then you understand how it is. One of the problems we have with these torches here is that we need to produce minimum 3 volts that we can cross the barriers that the battery can be charged. If you can put more cells together and you can find the nano layer gapping and the energy between the layers, you can buy any battery from any shop and charge it with your nano layers. In so many ways, you can put your GaNs materials in the car and just charge your battery with it as much as you like. They become your starter motor. This is what we were discussing years ago when I was talking to the scientists at Ghent University in producing electric cars. I was telling to Marco this morning. You can use the paint of the car. Now you understand that you can use as energy production to charge up your battery to store the energy for running your motors. Electric cars become unlimited mileage because you can do, we looked at maybe the nano layering of the roof, which gets less damaged. We looked at it, what happens if a door gets smashed in, so we lose the power. It's because you take energy as much as you need, doesn't matter if you smash all the doors. The battery takes what it needs. So new paints, new condition of nano painting can give you the impregnated painting that you can have a GaNs within the paint and then you have charged your battery. So you don't need to go to power supply. You charge your battery all the time. These are the new options. These are the new ways of adding to a new technology. This is what I kept on saying, and I keep on saying to the governments and to the industrialists. This technology will create more business than computers ever did, because it's taken us hundreds of years to generate motors and then the batteries and everything else. And now whatever we achieved in thousands of years, we have to convert them and use the new and the old knowledge with the present knowledge. And you find out everything can be revamped in a much easier way with the less demand on the environment, with the less demand for the greed of the man. So there'll be much more billionaires with the development of the new technology with themselves. This is what the true free energy is. A lot of people criticize us, you do this, you don't do that. We don't need, we teach you, do it. Now we've shown it. I don't do it. The knowledge seekers have the understanding, and that all of you as knowledge seekers around the world can start building these new systems and show it and develop it. And most probably a lot of you who love to be rich with these new even nano layers, which I spoke a few minutes ago, you all can become Gates, if that's your target. Because it's a new dimension, it's a new world of understanding. It's how you change knowledge. I was talking to the guys in Tokyo this week. It's very hard for them to understand. They're on the edge of energy production in solar cells and others, that now they can produce a 13, 15 kilowatt panel at the cost of less than $100. And the worst thing for them was to understand they can have both AC and DC from the same line. So what is the possibilities? The possibilities are huge, but now we open it up. Now we show it. Now It's not us who show it. It is the knowledge seekers, as you, as a lot, who started the process. Vince and Brad showed the first understanding, and we opened the doors. You start building the first Gans capacitors, understanding the magnet positioning. And then you see what are the possibilities open within the next few weeks. But you had to go step by step to do it, to understand it, to go to the next step. This is a nightmare for nuclear industrialists. As I said to the Japanese, you can give one panel to every household in Japan in next few months, and you have 9 billion energy, what do you call it, deficit bill, which they have. And then you understand what is the change to come. This is the tip of the iceberg in what this technology will change for all of you. If you understand what I explained about nano layering, and you understand how to create these positions, those who talk about 62 gigabyte computers, now you have a memory bank of trillion gigabytes in a small space. The game of computer storage, memory, information, if you understand this, has changed. Even from today, if you understand it, you can create the same as you do gravitational magnetic field information storage balancing. You make that balance for what you need. Then the game is changed. We try here in the foundation to build up these new systems that we can show it. Today, when I'll give the microphone to Marco, he has spent whole week making an ACDC battery, which takes AC and DC from the same cell, and he can show you how it's done. So it's not theoretical. It's taken him a week to build it. Next week, when we have 2 or 3 more layers, and we can produce, and we have the stacking, because Armin said, oh, we already have a stacker, because he was building a stacking for his dynamic small plastic reactors. Then we can adjust the height, we can adjust the material in each container, and then we have to produce a material nano layer which can absorb or detect energy between the layers. Then we'll see different, by moving the magnet of each layer up and down, we get a different energy from the system in charging up. Because then the field is given or taken from the bottom layer or layer. Then you understand the process of the nano layering. Now the nano layering is in a Gans level. Up to now your nano layering, which you have as a black material, is in the matter state plasma, what we call nano layers. Now you have Ganses of nano layers. The game of energy, storage of information is totally different. If you understand the process, and you can in so many ways understand that these Ganses in the small containers, in each of these orange or yellow containers, can be used. What you have now, you store your information in iClouds. Each one of these containers can give you as many iClouds as you can imagine, because there are millions of atomic, plasmatic Ganses in each container. The application of the storage of information now goes in 3-dimensional unlimited. But you have to tame it, you have to position it, you have to put it away. You can change, put the information, take it back out. For the first time, maybe we can show you, if this is extension to the knowledge, you can show them the brain in the back. You can adjust the camera. This is what you see in the pictures of it. We try not to move this thing. If you can bring the camera, you can see it from a distance. You see the sphere in the background. Marco is trying to set it up. See it. Just shift it very slowly forward that they can see to the camera, the ball. So if what I just explained, you could, if you understood what I explained, that in each container you have a GANs and you have a memory bank, you can use it very slowly. It doesn't matter. Just fractionally move it. Then you understand the working of this brain, which we put here as a control system. Marco, can we bring the camera forward and actually moving that? Then you can go around it. So what we explain in the nano layers, in the containers, what you see in the blue containers, and then conversion of the GANs to energy in the nano layers, we have built this, what we call the brain structure, months ago, and it's been sitting on it. You've seen some of these pictures. Now you can see the first memory bank brain structure in the same as what you see now in your GANs layers. When we spoke about it, for you was a bit far distance. But this is what, if you understand the nano layers which are sitting in these ganses of the copper oxide in this ball, then multiply this by the size of your brain. Then understand what storage capacity brain of a man is. And that's exactly how it works. Stacking of plasma in gravitational condition. This is what you call the DNA RNA information. DNA is a physicality, and the current flow between them in plasmatic level is RNA. So now if you just go closer, Marco, can you go close to the ball? Yeah, they can see it. You see, change the direction. You see the spots. These are cells which have changed magnetic gravitational level and position themselves as a spot. Go to the top, you see the top is water, it's liquid, which is separated itself. If you can show it, it's not flat. The magnetic gravitational field within the material has created its own hills and curvatures and magnetic field channels. Same as the brain. So what you have produced in these small containers, you can see the ripples and the little hills in the background. If you go the other side, Marco, they can see the little hills on it, or what I call the little lumps on it. You can go to the other side. The light is there, is no problem. You can see up. Go up, you're going down. Go up to the back. You see there are like small hills further down. I think you better see the picture yourself, then you know to adjust it yourself, what you're showing. You need to go down in the background to the wall. Then you see how brain structures itself. So this is the first three-dimensional computer memory bank, which knowledge seekers over time have generated from the day one when we made the first containers of the GANs in the lab. You see the spot, each spot is one gravitational magnetic field decided by the GANs itself to create. They were white creamish, now they became greenish, and they changed some back again to the cream. So what you see in the GANs materials in the containers, as I said with Armin, we're going to what he has in layers. This is the physical structure of when it's done in the total nano layers. If you put a pin in different position in this three-dimensional GANs, you have all the computers of the world put together at the moment, anywhere in the world on this planet, will not add up to a fraction of the capacity and hold. You need this kind of memory capacitors in deep space to store information about every magnetic field position in the universe. Because then you locate your position according to the sphere shape of the universe where you want to be, and that condition replicates in your reactor. These are the things that we teach in the future, as you understand. Now that we've gone a step further, you understand why these things were done months ago and how slowly we are taking the knowledge in that direction, that there is no magic. Then, on the other hand, I was explaining to the knowledge seekers this week, if you understand the neural layering, the way it's set here, and you understand the structure of the brain of the man, through this technology we can reach the emotional part of every man on this planet, that fighting, aggression can be changed and does not exist. But in us changing, man will learn and will do it again. But if the man decides to do it himself, then it will change permanently. So in so many ways, we are showing what is about to happen in the coming time. When I put this slide here on the table, the knowledge seekers who are listening and knowledge seekers who have been here and see this, I told them, when you unite as one, then you can control the brain to control the reactors in the lab. And now you understand how. Each brain is like one of these green containers on the table. They have to collectively interact to be able to create a field balance that it can interact with the other one. So in so many ways, as I said, we enter the defense technology for supporting the governments to stop a lot of mayhem. So a lot of people with the animal thoughts which are running around and doing what they like, it's within the knowledge of the foundation, and we will pass the knowledge to the governments to stop the mayhem which is happening in Middle East. In cutting people's head does not solve unless you can change the head who does these things. These are the very advanced space knowledge technology which we share with the man. But for man to understand how to use it the positive way. The whole process, the whole structure is how things have to be understood as they are. Here on Earth, you work with the matter, call it copper aluminium. In the universe, you work with the plasma strength magnet. So, in reality, it does not matter what GANs you use. You use the GANs at the level which is operational, detectable, and understandable at your intelligence. This is what I showed to the knowledge seekers this week. They wanted to see how the GANs levels are. And in the lab, we have 3 containers which are all like copper oxide, but different shades of blue or green, according the way they were made and the energy they absorb from their environment in conjunction with other plasmas. This is what sits in the next level of understanding. This is what you got to extend the knowledge. Other way to do it, make a double layer containers, very much like a pyramid, and fill up each side with one type of nanomaterial, GANs. And then you understand the power which sits within the center, within the structure of the whole pyramid. Then you want to higher energy, you go in different direction of the pyramid. You go lower, you go different direction. The control system of the space reactors of the future is very much on the pyramid structure where you want to move, and as you shift the gravitational magnetic field to that point of pyramid, because you see the structure of your reactors setting in a star formation. The star formation is a pyramid formation, and this is something nobody understood from the beginning. In the control systems which you develop in the future, you create the same formation on your table. And then you decide where you want that magnetic gravitational field of the 4 reactors to sit. And then they balance themselves in that position. In that position is compared to the universal position, takes you to where you want to go. It's a very simple system control, but you have to understand how to bring the materials together and understand the interaction of it. As I said to Armin, we have for the first time 4 reactors which are exactly identical. They're all made from the same material, they cut from the same copper, they are filled up from the same GANs, from the same water. They are exactly copy of each other. So now we can create a full balance pyramid structure, full balance gravitational magnetic fields to achieve what we want and to extract energy as much as we want. The new reactor should be with us this week by the Italians. It's a small version. It's one of the reactors which Arman brought with him. So we are adapting it to see how we can extract the energy of the GANs in the plasma state. And then we show it. You want 3 kilowatts, you want 10 kilowatts. It's what the system can deliver according to what the demand is, not just to produce. Then you understand the new development, then you understand what's been taught here in the center. We try to cover what we talk about during the week here in part of the, what do you call it, part of the knowledge seeker sessions like this. But then you have to understand the whole structure of new plasmas, new reactors, new systems. Maybe it'll be a definition for what the professor said, explain your plasma in a different way. We call it Magrav plasmas. Maybe we call them the Gans plasmas, but this is what this is the interaction of the fields which you have. As I said, you cannot have fields in the universe, because the minute you create a field, this field has to interact with another field. So the consequence of it is gravity or magnetical fields or reactions. Gravity is a reaction, not a field, because gravity, the process of gravity comes from the interaction of 2 fields. So is a byproduct, is not the end itself as an entity. And then when you have the gravitational magnetic fields interacting with magnetical fields, then you have the mass. Because whatever is the balance between the two gives you the mass. That's why the mass is always constant for elements. Doesn't matter in which environment they are. The weight is different, but the mass isn't, because the gravitational magnetic field which comes from the center through the interaction of the fields of the plasmas of the element is always constant. That's what the mass is. Then, if you understood this, then you can convert this into the mass of a plasma, into a mass of a Gans, and as you dream to have fusion, you can add the plasmas together in the plasmatic level. Then you have the true fusion. You can go from copper to double copper, triple copper, but not in a molecular structure, but in adding to the mass of the plasma. Then the game of the universe opens up to the man. This is what you have to go through step by step. We went through step by step. A lot of people were waiting for the reactors to do this, and then we built, and somebody wrote, oh, he hasn't given the key, he's a crook, he's hidden the key. The key was in front of you, but you don't have the insight to understand, to see it. The understanding of the interaction of the gravitational magnetic field is the secret, is the key to be able to operate systems. So the people who don't understand, they have to say something just to confirm they exist, because otherwise they don't exist. You've got to understand how you created the plasma through the rotation of the plasma, through creating layering, then understanding of the production of the gas. You change now the gas layers to produce a plasma to the plasma itself directly, which is a gas. That's why you see a smaller cores applicable with what Armand is making. Because now you deal with a GANS plasma, where in your nano layers, in your gas layers, you try to create that plasma. In a space there is no hydrogen gas, and there is no oxygen gas, and there is nothing else. Everything, majority is in a field dimension. So now with the ganses, how you understand to store the energy in them, you can always receive energy and convert the energy into a plasmatic condition, into a gans. Then the game is totally changed. I think if any of you who are wizards in the computer production and you understand the memory cards and all these things, understood what sits on the table, exactly like even this which Marco has made. If you can show your the reactors you have, the small one, the blue one, yeah. If you understand this, the working, bring it forward, they can see it to the camera. Yeah. This is the, each one of these is one layer. I think it's us which doesn't see because of our laptop, otherwise they see it full color. Yeah. If you look here, yeah. No, here you are good. Everything is good. You see each container is containing one GANS container. And this is the torch, we can show it the light on it. This is what has been charged up, full value, from the process. If you can go up a bit, you can see the full light. You're off center with your light. You can show it, but it's no problem. It's the battery is fully charged. In so many ways, you cannot focus it. It's okay, no problem. It's there. So if you look at all these orange and blue containers and the green, the GANs which sits in each of these containers, which is a few milliliters, has more capacity than the whole, what do you call it, the computer systems you have, if you know how to change and how to convert. So the process is understanding now the new elements available, the new conditions of elements available. If you, it's okay, there's no problem. But if you look, show what you've done in yours. I give the headphone to Marco to explain to you how he's done, how he's built his system. Then you see how he has come with the ACDC connections and the rest of it and how it works.
Yeah, hello.
Hi, Marco. Thank you, Mr. Kesh.
Hello. So I have 24 containers. In each of them there is GANs material, and on each container I have 3 electrodes. One is central electrode, which is nano-coated, and there are another 2 electrodes which are just metal electrodes, different metals. One is soldering metal composite of tin and lead, and the other is just ordinary zinc coated wire. And I put the connections from one container uncoated electrode to the center of the coated electrode in the next container, to directly to the copper, and another electrode goes on the surface of nano-coated electrode, so it doesn't touch copper inside. It touches only nano-layer, nano-coated electrodes, only nanomaterials on the top. And then I repeat this to the next cell, and I put them in series. So I have 4 rows of these connections, and this is actually its prototype version. That's why you see these wires here. So that I can try different connections. I can put them in parallel, in series. Yesterday I tried different connections. I tried to use them in parallel, and then I connect them all in series. So now at the moment I have 24 cells connected in series. So then the start, so here the first electrode is connected to positive, so it's connected to the diode bridge on the torch, and the end electrode on the other side is connected to opposite side of the diode bridge. So here with this diode bridge I can transfer AC to DC, and also DC goes through it to charge the battery. Actually, I can light also LED without battery, but it's not the light is not so strong. That's why we are using here battery to charge it. And yesterday in the afternoon, we connected the light of the LED was very low, and now even in the evening it was much stronger, and now in the morning it's also very strong. So the battery is charged. So that's why this week I went to electronic shop to buy this diode bridge and other diodes, and I think that's the last time I was in the electronic shop. When we came back, as also Mr. Cash explained, he asked us, "Why do you need to buy this?" These electronic components, when you have all the material here that you can use them. So now we have to try to use these nano coatings and nano coating wires and GaNs material to convert AC to DC also, not to use diode bridge anymore, and also to use batteries as a storage for the as energy storage. And I think that's the next step. My mind is still working as I was trained in electronics, and it's quite difficult to change this way of thinking. I have to look at it completely in a different way. It works automatically. I'm not used to this thinking of storage of energy in a GaNs. I'm still thinking in an old way to store it in a battery, but that's the next step, to store it in a GaNs, or to get these interactions between layers and to extract energy. But what is important is to extract only amount you need at the time you need, and nothing more. And it's actually, I'm asking several times myself, do we need to produce these kilowatts and megawatts or whatever, if we understand functioning of our body, it works in nanoscale, microscale, and we should learn how to use this energy level to sustain our life, and not to take from our environment more than we need. We were discussing this week also about how to make also smaller, how to make smaller containers, how to miniaturize this setup, and to make as small as possible. And there were different suggestions. We were also calculating how much energy we can get out of, let's say, 1 square meter of surface. Actually, don't need to use only one side. We can use two sides, comparing to the solar panels where they're using only one side. Here we can use also the bottom side. And this is more or less engineering, how to put things together, and we need to find people who know who know technology, how to put this in very miniature scale, so that actually here is just we are showing the concept of fields interaction and how we can extract energy out of that, and this should be developed further to for usage in different applications, for, let's say, for energy production, or even for the storage of data storage, and also health applications. So if there are any questions.
Thank you,
Yes,
Marco.
I do have a question, Marco.
Yes.
I was just wondering how you were finding your running the series or parallel. Do you find that it does follow the regular laws of electricity, as in addition in series of the voltage, or do you find something different?
It's very strange behavior. When I put them in a series, I get higher voltage. I tried also to connect them in parallel, but voltage, when I put them in parallel, obviously I didn't get enough voltage to start charging the battery. Battery all has this this barrier and needs some certain voltage. It's more than 3 volts, so that it starts charging. And so in a parallel, I didn't get enough. So yesterday I didn't test more in parallel. Actually, I just connect them in series to charge the battery. And what was interesting was also that in some moments I could get out of the system about 10 volts of AC, and then after 1 hour I couldn't get. There was zero. There was no more AC anymore. Then later, after 2 hours, I was again able to get AC again. And
then is the DC about half the voltage of the AC?
Sorry?
Is the DC voltage usually about half the voltage of the AC?
So the voltage of the DC depends if I have if I'm charging. I got about 6.7 volts, something like this. And when I'm just measuring, it's about 10 volts, 11 volts. What was the AC? No, it was not half. I think it was also AC. Yeah, AC was also 10 volts.
Okay. But when you add the cells in series, does it add up as in if you measure, let's say, 100 millivolts off of one cell and you have 3 cells, does your voltage equal 300 millivolts?
Yes.
Or
Yes.
does it fluctuate?
Yes.
Oh, it does. Okay.
Yeah. It goes up. I could not say exactly. It adds exactly. Let's say if you have 1 volt at each cell, you cannot get exactly 3 volts. Maybe you get 2.8, 3.4 or something. But in general, we can say that it is adding.
Okay, good. Thank you, Marco.
You're welcome. Actually, I have to study this. As I said, this is a prototype version, and I have to go deeper in understanding of this. Now, I have to look at it from a different point of view, more from MAGRAPH point of view, not from standard electronics point of view, and try how to convert this energy. This energy obviously is here. We can collect it. Here we are just converting it to normal electricity. But that's not the final position. My aim is to understand the plasma flow and how to convert this plasma flow, how to store it, and to understand
Right,
this.
because it's all about the plasma flow.
Yes.
Right. If we have a stronger flow, that means we have a more energy available. And of course, with a GANs as a plasma, able to provide a certain flow with whatever type of GANs that you're using, the interactions of the different nanomaterial and the different GANs will create a different flow.
Yeah. When there is a strength difference, you have flow of plasmatic magnetic fields from one strength to the other. So we have to use different GANs here in this configuration. I'm using only one GANs. I'm using copper oxide GANs. But I was planning to put on the end of each row other GANs, let's say CH3 GANs, and to see what the difference is. That's why I have this wire that gives me some flexibility, so that I can connect different GAN cell in between them and observe the difference in the flow. But again, we are measuring here in just voltage and electric current, and I think here we are also limited with this with our measurement equipment, and we have to understand this conversion from plasma to electric current. That this is only a partial flow that we are measuring here. It's, I think.
I do have a question that kind of relates to, and also what Mr. Kesh was talking about here at the beginning, about the addition of a plasma into the GANs to be able to have the mass of the fields that are, let's say, in 3 carbon atoms. Would that be an encapsulation of the GANs and the plasma, or would that be a plain addition of that plasma to the GANs?
It will be, as I understand, it will be encapsulation inside the GANs. You have GANs as a sphere. It's which has the strongest principal field inside in the center, and when it radiates out, when it interacts with environment magraphs, it creates this magnetosphere that you see, this this matter of plasma which is floating in the water, let's say. And
so we could basically call that the structure of the atom as we see it with the electrons, as in the different states of the electron in terms of its distance to the plasma of the center of that atom. So it's kind of like an encapsulation that way.
Excuse me, perhaps we could get Lucien's question in now. It seems he sent a drawing along just now, and of the CO2 GANs, showing it as the atoms of the oxygen and carbon, and then combined as the GANs and combined as the combined fields, let's say. And it seems to be on topic of what you guys are discussing there. Maybe he'd like to come in and introduce his question about the CO2 GANs.
Actually, each GANs is one entity.
Yes,
we don't have atomic structure anymore. Okay, go ahead.
Can you share your screen, Rick? So. Okay, sounds good. So I can go ahead. So basically, this probably will be for Mr. Kesh, the question. So basically, the regular CO2, as was depicted in figure 1, is having more or less linear structure. Sure, some angles and it's vibrating. I think you can go to meeting. Rick is sharing.
On live stream.
Live stream? Oh, okay.
Yeah.
Wait,
make a direct transfer if you
go
can.
on live stream.
Just try. Yeah, please, Rick. Yeah, just try, please, Rick.
There is some, I see some picture here, but to put this on the
So Rick, okay, it's good. Yeah, it's appearing. So I will proceed. So in the regular matter state, the CO2 is more or less a linear entity. Sure, it may be some distance between the atoms, some angles, and they will vibrate, which are not interested because we don't do here spectroscopy. However, in the gaseous state, as Mr. Cash explained, so I want to make sure if we understand correctly, as it is in figure 2, all the electrons or any nucleons or whatever they want to name the subatomic particles are somehow bypassing the Coulomb barrier. That means is disabling it or passing it, whatever that situation will be, and is increasing the radius of the entity. We don't say it whatever, gas, nothing. We name it entity. So the dashed line, the dashed lines are showing the increased radius of the sphere. Well, we'll name it plasma or Gans plasma. So this is one fundamental entity, probably that we are naming it Gans. So now, as Mr. Cash explained, we don't have any more north and south pole. We have output and input depending on the flow of energy, magnetic field. So now when two entities of gas, whatever that could be, but I'm insisting on the molecular side because it's easier to understand than, let's say, copper. One of the entity is binding to, let's say, the output of the figure 3 is aligning with figure 2, which is the input, and is creating what we are calling in the mainstream physics a dipole. Sure, there are a lot of simplification so that we understand the concepts. There are a lot of these dipoles. So on the bottom of the picture, I was just depicting 3 such of Gans entities. So 2 of them, they are positioning, as Mr. Cash explained, to the third one. And the line LF means the field lines of the 2 of them are somehow positioned on the line fields of the other one. So now, as we understand this, once we rotate the sphere, the reactors, all these dipoles are starting to interact with each other and generate field. So now I want to come back to the previous workshop when our friends from China did some analysis on the equipment and they didn't get the CO2. So if probably they did the Raman spectroscopy or something else, but if they will do a nuclear magnetic resonance spectroscopy, I think it's obviously for anyone that the magnetic momentum, the inertial momentum of a sphere is completely different of a linear or some sort of structure. It is in material level. So technically, if anyone will have the possibility to do such an analysis, the CO2 Gans signature shall be very obviously and evident. This for eliminate controversy. But from our point of view, surely the radius of the plasma of the CO2 probably is larger than the copper. We have to look on the atomic masses. So now, based on the ratios, because I'm building on what Marco said, based on the ratios of what the amounts of, let's say, CO2 Gans versus copper, and of course, comparing with the atomic masses, probably one should start to understand the specific rotation of the sphere. And I was explaining that the group, you will have some air there, some nitrogen, because you don't vacuum. So you will have some electrons, some rotation, cycle frequency of the electrons. So a specific volume of the sphere and a specific volume of air or water or volume of the gases, one should start to see some separation and layering, and we can take it from here. If Mr. Cash agrees with this theory, I may be wrong, but this is what I understood. So this will be the first, let's say, not necessarily question, but some sort of exposition. And the second issue that will be the question, Mr. Kesh said that between these container of the gases, we should have some sort of electrodes with some other composition of gases. I think it will be very nice if he can elaborate on this, because we observed in the group, and Vince saw that at 5 micrograms, 10 micrograms, you cannot lit a lead. So as Mr. Kesh explained 2 workshops ago, we are just measuring the difference between the fields, not the field itself. So once maybe Mr. Kesh has some hints for us how to do these sensors, think what he explained today. Playing with these little containers with gases will give us an overview of how to proceed. So the question will be, how could we try to proceed to do these sensors? Thank you.
Going back to your figure 2, that is what you look at the matter atomic structure.
Yes, figure 1.
So figure 1. Figure 2, you show a CO2 as a Gans on its own. So then what is at the bottom picture of it? Your figure 2 has 2 spheres.
There are 3. Yes.
You're considering
so
2 CO2 Ganses.
Right.
So in the figure 2, you have 1 CO2 as 1 plasma. And now you have the interaction of 2 plasmas of 2 CO2s. Am I correct?
Yes.
So you have exactly what happens in a normal condition magnetic field flow as the plasma and gravitational magnetic field positioning. The gravitational magnetic field of the copper plus the oxygen, or carbon plus the oxygen, creates its own individual cell. Okay, CO2 or copper oxide, it doesn't matter. You take the top one as CO2 and take the bottom one as a copper oxide, because we mix the gases together.
Right, you could classify it as well.
Yeah, so each one has its own gravitational magnetic field, and the interaction between those two creates very much like electron and a proton, their own gravitational magnetic field plasma condition, because they have to find a balance. So you have a CO2, and let's say you have a CuO in the bottom. Each one has its own plasma, its own gravitational magnetic field, and the interaction between the two creates the total plasma as you shown it in the dotted line. Then that is the field or magnetosphere of the interaction of those two plasmas. And the flow is the same. But then you can have, depending on the forces of the other plasmatic magnetic field of other CO2s, because of their positioning and the strength, some of these plasmas will flow the opposite way, which the out goes to the bottom and the in goes to the top. This is natural. This is exactly what, like Venus has that position, or you call it positron.
Right, I tried to show this in
figure 3. So this interaction of the gravitational magnetic field of the entities of the plasmas, when you have such a large number, due to the magnetic gravitational field balancing, not all of them will follow the way you have put in figure 2, outs on the top and the ins at the bottom. The field forces in the environment of the other CO2s and other copper oxides or whatever will the field or the positioning of the out to be at the bottom and the in on the top. Change of polarity or change of
Yes,
direction.
I agree with you. I will try to modify
So,
the drawing to show
yeah,
it also.
okay. Now what happens is that the interaction, the way you show it in figure 2, will lead to the interaction of what we call gravity, creation of a field of gravity. And then when the other one turns that the out is at the bottom in figure 2 and the in on the top, then that leads to the magnetical field production. But you still have the same atmosphere of the totality of the balance. This is exactly how gravitational field and magnetic field in planets and in the stars are created. Because all the plasmas, because the magnetic field of the Earth is north to south, the way we call it, are not necessarily that way, because the environmental plasmatic magnetic field of other matters will force the creation, condition, spacing of the change of the polarity in some of the fields. So when that polarity change or rotation of the north to south from is done, then that field interacts in the similar polarity or dissimilar polarity, becomes a gravity and magnetic field. And at the same time, the same element due to the field force of its environment can change back polarity to the top. That's why the sun changes polarity. That's why the Earth changes polarity. When the current flow balance is created within, then when the flow changes. If you look at it in your nano layers, you see this when you go from positive to negative flow. It's the same process. There is no difference. But how are you going to measure these fields as you're asking your question? Like when you go to your figure 3, or the one, the figure at the bottom, then you have to measure the field flow between the what do you call it? The field lines, depends if it's a positive or negative, and what is the balance in that environment. And you measure it in respect to into a base flow. Here in the lab, we use the Earth gravitational magnetic flow as a base, as what do you call it? As a baseline, as a reference point.
As a reference.
Then you have to then we calibrate, because we have a detector which sits outside, which is the environmental gravitational magnetic field. And then we have a detector which sits within a set, enclosed. And you have to be in the same position, same direction to be able to have a reference point. What we did last time before summer holidays with John is that we put a table and we put the detector and we assume the imaginary reactor on the table. And we start measuring the fields in 4 directions around the table as we're looking into this imaginary, what do you call it, reactor, to get the field reference. And we saw huge differences if you go from the phase, which is each phase in respect to each other. And when we set up our detectors for the second set to looking into the field of the star formation. Then when we change the detector from one side to the other side of the formation, we had a point of reference in respect to that direction on the table which we had. And it's a big difference. We kept the data is all written down. So, for example, if was a facing side of to us, the table, let's say it was 0.6, on the one on the left-hand side facing the same imaginary point was 0.4, and the one, for example, facing us on the other side was 0.7, because the fields coming into the reactor in that direction. So we made a reference point in respect to that wall, to that position in that direction. And that's what we do. We make a reference point. Even Armin started the new reactors yesterday or this week with the small reactors. He made a reference point a meter away and then closer, and then fix that position in respect to the reactors is setting up. At the moment, we take the reference point in respect to environment we are in. Till in the future, we can make a standard form for this is this position, this material. And this is one of the extension to the knowledge which is now is happening here in the lab. As I said, for the first time, you said how we're going to collaborate, calibrate this thing. At the moment, we are in a totally different position with the new reactors with Armin. We have, for the first time, once we start setting everything up and the way it's getting set up, we have the same copper, we have the same reactor position. Now we fit in the copper coils with CO2 and we measure the field in respect to the speed of rotation and without rotation. Then this gives us a CO2 point of reference. Then we change it to copper oxide. Then we change it to the next material. Then this starts giving us the data we are looking as a reference point for the materials. And then we say, okay, this material at this point within distance, like, so much, 10 of these millimeters together makes 1 centimeter. Then we say in this distance with this composition, with this percentage of copper oxide becomes a reference point for the measurement of the copper oxide gravitational magnetic field plasma. We started setting up this data as part of the development of the material we have. It's the first time you are not in that position. We are lucky to have Armin with us, and he made these small reactors. Now we have a copper fixed. Now we can add 2 coppers. We can add a copper and a copper oxide and a CO2 and start developing these measurements. That's what Armin done. Armin has made a sheet and everything is getting written down. What you get in the x-axis, what you get in the y-axis, what you get in the z-axis, in the atmospheric base condition of when he's done the measurement. We are building up the data. So then we give you the point of reference, because it's the balance in respect to the environment at that day when the test is done. Adjustments can be made. That's why hopefully in the coming time we put this set which Armin has made into the box, which is a zero condition environmental independent. Then we can give you the data. Armin has started building up this data. Now we are working with CO2. Then it'll be after the next couple of weeks, we look in the Gans. We look at the mass reduction, how much at what speed, what mass reduction we get. For example, Armin can tell you we started at the new setting was at 2 kilograms, 2.66 kilogram. and we went down to 2.64, which is the normal variation in the lab. And I said to Arman, if the field flow balances, by tomorrow when we come back, it should be around about 262. And when we came in the morning, it was 262. So let's say 20 gram reduction is nothing. But then we see next time when we add now we are going to the second reactor and the third reactor and the fourth reactor in the structure. Then we start building up the measurements, positioning, magnetic field, which gases in what position it gives. You got to realize each knowledge seeker here is developing different aspects, but collectively we work together to develop the totality. So we have a new reactor coming back from the Italians, which we gave to them to measure the current flow within the plasma of the CO2, but with aluminium. So we will see if it's the same when we hang it on its own in the center. What would aluminium give us with CO2 with that composition? Then we start what do you call it? Measuring things. The whole setup is measured according to what it is and where it sits. The whole structure, it needs to be set up. And now we are comparing the same with the same. So one detector is measuring exactly what is in the copper as copper with CO2 or with the other one, and how the measurements are set. Because now you have a matter copper plus a Gans of copper, which they are going to be interacting. So we have to use a field detector which takes into account the copper as a mass, as a matter, not as a plasma of the Gans, and see how much difference that plasma creates inside it. So the data coding will come now. We can position as you shown in your drawing. We can show the flow with the detector in different position, in different height. We have that flexibility here to create and measure the fields in respect to each other. Now, this week, Arman has done one reactor in the center. Now he's going, hopefully today he's received the motors, he's going for 2 reactors. So we can show the interaction of like 2 CO2s with a copper containment. Then the data is getting built up, and most probably we don't see the whole, we will not understand the whole interaction of the data in the future. Some scientists will go through the same data and they'll come up with this, what we missed or what we didn't understand. This is natural. But now, if you look at the other core reactors which we had and we built in the first part of the year, each one was different. Was steel, one was copper, one was plastic, different kind of plastics. Now we have a half or full, as John says. Now we have point of reference for exactly the same. Now we start building the data. There are those who criticize whatever we do. These are because of their lack of understanding. This is the way they can prove they exist. So we ignore it. The knowledge is to add and see what we can add. There are those who always say, oh, there is this, there is something wrong there, they don't do this, they didn't have that. So that shows they use what we don't have to show they exist. So you have to ignore these kind of people. But in reality, the data is getting set up. Is gradually we're getting there, and the knowledge seekers have to understand what they are doing, what the process is. We are far away from the day when we made the first bottles and John was praying over it to show some energy, and and others were disappointing, marching out of the lab. Nothing was happening. It's the same Gans. At that time, they could not understand. Now they see it, they can analyze it, they can add to it. It's just at the beginning has been it's hard to put things together, to add things together. Now we are getting collaborations from institutes, from universities, in a way that we can release data, we can speak, we can talk to them, we can tell them what we have, and we add to the knowledge as we go along. There is no comparison to 4 or 5 months ago when we were in the lab here. Now we have a different position. Now Arman is pushing to build the new, smaller reactors that we can do more. We can rotate the inside and the outside. As I said to him yesterday, we've got to wait. We've got to understand where we are before we develop the next fields. Yes. You want data?
Because you are at this point, I have one more question, which...
Yes, Carlos.
Okay, I have one more question because I feel that it's very important because you were speaking the last workshops about cleaning up one of the ends of the nano-coated copper wire, and you get at the interface, I mean on the bare copper, you get AC, and on the nanomaterial DC. So I have one of my goals is to get some sensors to help us out. So what I did, I'm telling you what I did because you may have some suggestions to expedite this process. So in a ferrite, you know, that thing that you put on the transformers, I had a hole, which is very difficult to be done because it's very, very hard material. And that one I filled with CO2 gas and sealed it. So in other words, it's like drilling a well, to be very simple in explanation. So this was assembled in a regular transformer. And it happened a very strange phenomenon. If from 3 cells, 3 cups, I got maybe 1.2 volts on a capacitor, and the moment in which I was putting this thing in series, so the transformer with the core, the ferrite core drilled and filled with gas, it jumped up to 6 volts. Apparently, any DMM meter was showing 0 current. So I was thinking, is any way, we know that the ferrite is some sort of mixture of oxides. We can take a look on the chemical structure and composition. But do you think that is anything I can do so this gas inside the ferrite to enhance its field and to generate some voltage into the transformer coils? Because if you think to some sort of idea, that means if we interpose this little transformer between 2 containers, lens containers, as you suggested about maybe 20 minutes ago, that means you can have a very cheap sensor, which as you move it in the 3D space, will tell you by voltage what kind of interaction do you have. So that would be the question. Is any way in which, because now I'm not getting any voltage from the windings, it's just somehow enhancing the field. So I feel that this could be a groundbreaking new type of sensors, if you can elaborate on this.
I don't know. I look at John. John doesn't look at. We don't understand. Can you explain yourself again? Go back to point. Say exactly what you've done.
Yes, I got a little transformer, as that ones that are in the cold cathode tubes and laptops, and I had a drill the hole into the ferrite. It is an E shape, so in the middle leg of the E, I drilled a hole. You know, like these guys are doing with oil. just a cylindrical hole, mechanical drilling. So that hole, I filled it with CO2 gas, and I sealed the drill. I closed it for not leaking.
Yeah.
So, and the moment in which I connected this, the windings of the transformer in series with the 3 cells and an LED,
Winding
the voltage
from where? Hold on.
From
Explain. Winding where? Round the middle leg of the E.
Right, that is the regular transformer winding. Right.
Ah, okay. Now we understand. Yeah. Carry on.
Right. So the transformer has about maybe 2,000 turns of copper wire around the E ferrite. Right. So
so you hold on, Lucian. Let's go step by step. You filled up the hole with GANs and you closed it, and then around you put the winding around that center leg of the E.
Right, but it's already done because it's a transformer.
Okay, yeah. Okay, I understand. Okay, next. Carry on.
Right, so the winding of the transformer, I had it in series with the cells and one LED.
Yeah.
So as usually, the 3 cells were giving me about 1.2 volts on the LED. In the moment in which I connected this...
Wait. You were getting 3 volts from the GANs at 1.2 to light up the LED when you were inside the GANs. Am I correct?
Right, from the 3 self-only GANs was about 1.2 volts on the LED.
Yeah, but you get nothing from the winding.
No, in the moment in which I connected the windings, the voltage jumped to 6 volts. It's like 4 times more. But
in the windings, which is outside, just on the leg of the transformer.
Right, where is connected the LED, right. So the voltage is increased about 5 times. But the current is still 0.
No.
The DMM is showing nothing.
Okay. That's we 3 of us here. We're trying to understand what you're saying. Then we can hold on. John has a question.
Okay. Yes. You have the E of the transformer. You made a hole in the center leg of the E.
That's correct.
You put some GANs therein, and do you make any connection to that hole, or to the GANs inside that hole, or not?
No, that was just sealed for not leaking with a piece of plastic.
Okay. You don't make any hole in the other legs of the E?
No, that was done purposely for unbalancing it.
Yes, okay.
As Mr. Cash is saying, create turbulence. Yeah.
Yes, so the cells that you talk about are cells outside of that transformer.
Right, the 3 cells are whatever as you did, the regular cells with the electrodes.
3 cells.
So
and the connection. And you have the connection to the cells.
Right, so when I'm putting the LED with the cells, as you are doing, let's say, I have about 1.2 volts on the LED, more or less. And
that's
now I'm disconnecting. Okay, go ahead.
LED should be red or green, maybe?
No, that's irrelevant. Okay, explain
for the one.
Now, how do you connect the...
I have a red one.
Okay. Now, how do you correct the winding? This is the question.
Right, so...
does that picture I put up help at all, Lucian?
Not now, maybe for next time, but it's simple. I'm just disconnecting one of the legs of the LED, right? And I'm putting the winding of the transformer in series.
With that leg?
Exactly, right.
What's the LED?
So,
yeah.
is like having another cell, but instead of being a cell, is the winding of the transformer.
Mm-hmm.
I can draw a picture for the next time, but it's just
We're trying to understand. Okay, what happens now?
Right. So in that moment, the voltage goes to maybe 5-6 volts.
Yeah.
It's 4 times more.
Yeah.
So my
But
thinking was...
Does your LED come on? Does your LED come on?
Yes, it does.
The light? Okay.
So I was thinking to use that transformer like some sort of sensor, based on what you said today, because if you put more of these lens, what they're calling, lens holding containers, and you want to measure between them what is happening. I was thinking that if you modify this, maybe put on the other part of the transformer copper GaNs and the other side CO2 GaNs. I don't know. This I was asking if you is triggering some ideas on your part.
So by adding, in a way, a fourth leg, or a fourth container, but instead of putting the electrode in the GaNs, you have put your electrode around the container of the GaNs, and putting the other 3 containers in line, you have increased the voltage from 1.2 to 6 volts.
Yeah, more or less. It's 5. Yeah, it's very easy. 5, 6, yes.
Yeah, 5, 6. Okay, now I understand. But your current flow
is 0. The DMM it's flat 0. So apparently, scientifically, it's how to say, it's completely
LED,
0.
LED is lit.
as John says,
Yes,
it's a LED lit. So you have a current flow.
Yes, it is.
So you have a current flow, but you have a higher voltage.
Yes, you have a higher voltage. That's correct.
But you have a current flow. Otherwise, your LED doesn't come on.
You are right, but is extremely frustrating because the DMM that is supposing to measure current is 0, and I tested with a regular bulb. It's not damaged.
Yeah, but you have, your current flow is 0, but you still have a LED lit. It's still it's lit.
That's correct.
You can see the light. So that is normal. It'll be interesting.
So I was thinking
Yeah, I understand what you've done. This is a voltage booster. What you are doing, you are. This goes. I would like to explain to you, but this goes to weapon technology. What you've done. It is very correct. You don't see any current on your voltmeter, but you have a current that it lights up the LED. But before you see a current when you had the 3 GaNs containers in series at 1.2 volt. Am I correct?
That's correct, because then I have just a capacitor. Yes, I have a capacitor and it's discharging on LED, but you have to wait maybe 5 seconds to charge it.
Sorry very much for interrupting. It happened many times in such experiments that somebody could not measure any current at all. Usual reason is if measuring on a wrong scale once, there is a little fuse inside the multimeter, a value of 250 milliamperes, and sometimes that gets burned. So have to check your ampermeter if you can measure current on any other source. If you cannot measure, then check the fuse within your multimeter, because that may be burned.
No,
Yes, I
No,
did check
no.
it, and it's
No. You got to. I think you're correct in what you're saying, but the point is here that the what is the measurement of the current before you connect the winding when the LED is on? What current do you measure?
it's still 0 in both cases. Apparently, there is no current, which is unbelievable. But the LEDs, Vince had the same issue.
Yes. What happens?
It has
You are dealing. What you're measuring in a current is the current in the matter level, electrons. That's what your system is set up for. But your LED or your system, which work through, you connect it through the Gans or nano layers, still delivers the current in the plasma level. The reason you have a boost, and you see it in the voltage when you put it up, it's very much to do with the winding around the coil, the way you have done the winding. If you do, I tell you the reason I know exactly what you've done and why you don't see a voltage. The voltage, the current you have, you're working on a plasma condition. Some of these LEDs carry a special contact dust, which is a copper oxide. They actually use the specific kind of copper in the LEDs, which is most probably it is what you see. The same as the copper oxide and nano layers which you have is on the same magnetic field strength. Most probably no current flows through your matter what you're measuring, but the flow is in a plasmatic condition, in a copper plasma condition. This is a I have a coil here which is built for partially this purpose. Weighs about 3-4 kilos. This is very much you deliver high voltage, but in the electron level you see zero current. But in a plasmatic flow current you have a full flow. This is one of the reasons, if you look, if you go back to your Coca-Cola bottles, when you touch the electrodes, you see there is no voltage, and sometimes it's a rapid voltage and disappears. We saw it yesterday in measurements. We saw it today with John measuring here on the table. You have the current flow, but in the plasmatic magnetic field level, not in the matter level. And most probably your electrode has a
so
copper.
You need somehow to convert it, isn't it, by some mechanism?
No, you're not necessarily. You don't need converted. The electrode receives it and converts it itself. That's why you have the light inside the electrode, because of the structure of LED inside. You create that conversion. If you sit inside, literally in the electrode of the LED, you will measure a current. But outside it, you don't get it. And outside you don't have, because this is a plasmatic magnetic flow current. Maybe it's the first time you understand the difference between the two. The matter current flow does not necessarily mean plasmatic magnetic field flow, and the strength is totally different too. One of the reasons you see the boost in your voltage is the transfer and the difference between the layers of the nano layer and the matter. but because you're coming from a different field level, you're collecting. This is what I was explaining earlier on. If you put these nano layers and measure the gap in between them, the energy, then you understand the plasmatic magnetic field flow without containment. Just because you put the material you drilled it in the, what do you call it, in the E-leg, center E-leg of your transformer, you have captured the matter part of it, but dynamically the flow is still there. The plasmas, the ganses are releasing their magnetic field in respect to the environment. It'll be very interesting if where you made the hole and you put a GANS in, put a nano-coated layer and then fill it up with a GANS and then close it. And then tell me what result you get. You'll be very, very fascinated what you'll find out. This is part of the defense technology. In a way, you will.
So, excuse me,
carry.
just a second.
Yeah.
Please repeat once again. So I drilled the hole. I
You
was
know,
putting
the hole
CO2
you already
gas,
drilled.
and you suggest.
Yeah, the drilled. Yeah. Make film of the copper oxide and line in your gap with it. Try to fill it in without tearing your copper film. Yeah. No. In where he's put the GANs. This is what we do with what we had with exactly with John's reactor. The two half spheres. We put a layer of nano coating copper oxide inside, and then we put a GANs in. You create the same condition. So then you tell me what reaction you see. You'll be puzzled in what you receive and what you will see, if you can measure the right fields. What you do, what you have in the high potential difference.
So you are suggesting
filling up the hole
so
with
you are suggesting
the
that
lining.
to close.
Take the material
Of
CO2
copper
out of the leg of the copper GANs out of the leg of the transformer. Line it with a nano coated material if you can, and then fill it up again with the GANs material and close it. And then do your measurement and let us know next time.
Okay, I will do it.
Then tell me what the reason you have a high potential increase in your potential difference is because now you have a copper coil, which is not nano coated most probably, which is normal copper with insulation.
Enamel,
And then,
yes.
yeah. So you have a GANs interacting with the copper, and then that is totally different with the copper which is coming through the electrodes, the potential difference which coming through the GANs within the coated layers. Because most probably your three containers, you have a nano-coated element in them, I presume. Am I correct? Or is it just wires out of the GANs?
It's a bit. In the containers, I have just bare copper with zinc and CO2 GANs.
CO2.
Not coated copper.
Yeah. So that's what you have the difference. Try to use the same material, but you have the difference that you are creating. You're absorbing different magnetic field strength. It's very much to be inside the Earth atmosphere or be outside the Earth atmosphere. You interact, you're part of it, you don't see it, but outside you interact the way you've done the field. This is, you can do the same thing if you could measure it, then in the next step do it with the GANs material. Then you will see a totally different capacitor characteristics. But the potential, the reason you have a potential difference is you are collectively in your winding collecting the energy from the interaction of the magnets of the GANs, even though they are sitting there doing nothing, but they interact with the coil, and what you're taking from inside the coil. Try to change your electrodes to nanomaterial. You will see the difference. This is what. Let me explain something very. You know, we talked about the reactors we had that we put electric wires between, or wire coated between the reactors for the field flow of plasma. You have a potential difference in the material in flow of the GANs, but it's in a plasmatic. But the current flow as a current, as a matter, is zero. If you can measure current flow in a plasmatic condition, you will see that's why your LED is on. Your LEDs, most of LEDs produced have internally inside, most of them when they're manufactured, they use a dust of copper. This is part of the structure of them. And some of them they use a specific copper, which is because of your ganses, you can even have the CO2 GANs, but you create that condition that creates you work in the plasmatic level, not on electron level, current flow. That's why your LED is on.
Wouldn't it be to our advantage to go directly from, say, the GANs plasmatic state to, say, light, to convert something like a LED, a light emitting diode, but some sort of other nanostructure surface that will trade directly to light, and avoid the whole electron issue and trying to collect them with coils and this kind of thing.
That's what I said this week with the knowledge seekers when they came back with the transistors and the capacitors. This is what we got to develop, the next step. You will understand. You can use, but the thing is, don't get baffled that now we found this what we call the Gans state, and everything will gonna be that way. Use the mixture of knowledge between the matter, electrodes, and things, and you find out it will be beautiful, beautiful characteristics and propositions. You can use them as a boosters. Go from one Gans strength to another to the matter, convert your electrons, your DC into AC, boost it. Just because we work with GANs, don't get carried away. Now we can do everything in the GANs and have it. You can, you have to be able to mix, use the nanomaterials in conjunction with the matter, create your current at the AC level, boost it, put it back in the GANs and see what happens on the other end. And then you'll find out you have a collection of different colors and new exotic lighting and everything else and capacitors. As they say, don't throw the baby out with a bathtub just because you found a new, what do you call it, a new baby. Just try to understand and mix the knowledge together, and then you'll understand. You do more, but try to understand what exactly happening. Why there is nothing. I explain this to Marco quite a lot because I see him every time puzzled. It's do not get focused and say because I don't see it in matter level there is something wrong. Something is happening. Try to understand the process. It's just because the LED comes but there is no current, it means the current is in the plasmatic, but in that environment of the LED inside, because they use usually a copper known as a isotopes of copper 63 is used as 70%. That due to the condition which is produced gets very much nano layer oxidized. So without you knowing, in the LED there is a characteristics that produces that conversion for you. You got to understand the whole structure of the physicality. So to you, you have no current, but you have a voltage, and then you add the transformer, you get a higher voltage, but you still have no current. The current is in plasmatic, and the plasma does not need the wire you connect shows the flow of it, which way to go. That was same as we did with the wire in the course. But inside the LED, there is a manufacturing process which literally creates very much nano coated in a very soft way. So you get a conversion back to electric. And then your LEDs on, but
right,
you cannot
so
measure the light.
The next logical step is that if you want to collect that energy, how we can replace that LED with, I don't know, a coil or some sort of capacitor
Field.
plate.
Be patient. Be patient. You have to. Let's go through the process. Pardon?
To light it up, I think you need to have a nanomaterial.
Why don't you light it up with another Gans of different strength and create the friction between the two Gans states?
Yeah,
Create.
exactly.
Now you have the knowledge. Just play the game of God. Put the gravitational magnetic field of the Earth in front of the magnetic field of the Sun. You get the daylight.
So can they be mixed directly together, or do they require a thin membrane between them of some sort?
In a way you can do, but let's do it a step at a time. As I always say, the biggest problem for the future generation is how to keep a light off than to keep the light on. We spend so much money to create energy. In the coming time, you have to spend so much money to keep the light not to be produced when you use the Gans materials, because the interaction is always there.
You'll have to pay extra to turn the light off in the future, right?
You say you have a switch to create the separation, and actually having a switch to do it. But this is part of the. This is what go back to the lectures of early talks we had always said. In the future, you'll have more problem keeping the lights off than on, because it's in a plasmatic condition. Is to try to understand the process we are going. You're all experimenting new things. You discuss it. It's good. We learn. We all learn, but we all understand why. There is no magic if you have a LED LED, but you have no current flow. But go back, understand where does the energy come? This is not a free energy. Somewhere in your LED, you have a material which is a copper-based, is part of its development, or is a material which is not being copper, due to its process in the speed it's done, it's created a small nano layer, even maybe 1 or 2 nanolayers, not thousands. And that allows the gravitational magnetic field of the conversion of the field which is floating within and around the wire you connected. There is no magic, it's just understanding the process. But the copper 6365 is highly used in high definition electronics. And the people who are aware of it are worth millions per kilogram. So they find out, but when you do it, it's used. We are aware of the technology, we are aware of the knowledge, but there is no magic. You have an increase in the voltage from 1.2 to 5. This is understanding because of the coil system you set up and the way you You extracting energy from outside the interaction of the fields, even though you think you capped it, the plasma inside still flows. And then the energy difference and the part of the potential difference and the current comes through the process structure of the LED light. You put a normal light, which is not LED, and see if it comes on.
So it's my understanding that you are suggesting that, for example, if we get like a regular PCB board and it's done by, regular techniques to have a flat coil, and we are doing that copper nano coating on that one, that could be a collection or our conversion device instead of
Yeah.
LED.
Yes, in a way you could do it, but LED conversion comes. You do the conversion in your copper wires. You just measure the copper wire coated and not coated. You see the AC. That's your conversion. What about if you take a nano layer, do as we do with a cup of life, of different composition nano layers, and then you see what current and voltage you get out of it. Because then you create a difference between the nano layers. Very much the way you're doing with a nano layer and a copper, and you create AC. That process gives you plasmatic current between two plasmas. And that's how your body works, and that's why the cup of life works and looks to be working and does things. It's the same process, there's no magic.
So basically you are suggesting that in these containers, as the knowledge seeker showed, you do the copper nano coating in the regular way, just with sodium hydroxide, and for the conversion back into energy, you put, let's say, Coca-Cola bottle next to dope it with hydrogen or with other elements. So
if you can coat it with another elements, and then again coat it. We have called this is in the patents. You can read in nano patents. You can do it with different coat of nano layers, but you have to understand how to do it. Understanding the nano materials layers create their own magnetosphere, so it's very hard to get them together. You have to create a condition, choose a material which allows the fields of one layer not to reject, but create a close balance positioning in respect to the new material. Then you get your sandwich. Then you get your light. Then you get your current flow conversion. Everything has been taught. It is you who has to decipher it, to understand it. There is no magic in your voltage while you have a 1.2 and you have no current, but you see light. First of all, you have a plasma flow, and secondly, you still part of the reasons you see a high voltage is because your plasmatic flow from the coil is different than the plasmatic flow from the material which you bring from the three Gans materials. There is no magic. It's just that please start looking. Not part of the schizophrenic mind, but understanding of the total. Try to understand which of the two schizophrenic is talking. Then you understand, you know all the knowledge. Understand separation, separate it, and how, understand their interaction as much as you separate them. The zero current flow, you measure body's lights. Yes, there is. You have a plasmatic flow current. And that plasmatic flow current in a LED, due to the construction of the LED, the way it's processed, manufactured, allows a very fine nano layer to be there. And when you have a nano layers, doesn't matter wherever you are in the world. We put a small amount of gas in one core, and 2 meters away, we pick it up in another core. You're 2 centimeters, 10 centimeters away from each other. But with your wire, you dictate the direction of the flow. This is what we did in the lab. As I said before, we made the copper wires, Armand connected, or Marco connected from bottom of each core to the other core. partially is nano, there's a plasmatic flow that you directed. Doesn't matter how much you turn the copper around the building and go back to it, it still follows the same pattern, it goes the same place. This is part of the zero time communication. If you understood what you've done in your coil, if you understood what you achieved in boosting your voltage, and understand the current flow in the plasma, our Brazilian colleagues who are on the line, I know they listen, you achieved your zero time communication. But understand, there is nothing accidentally and it's no magic. If you see something which is there and to your understanding it could not be there, why is there? It means you have missed the point. Go and follow the point. There is a current. There is a plasmatic current. The plasmatic current, due to the construction of the LED, has a nano layer inside it. Then think of something else. What about if you fill these nano layers in LEDs with a GaNs, with a conversion of the material to electrode, back to GaNs, back to nano coated? Then you can light up as much as you like. It's just, there is no magic. To you it's puzzling, but if you now understand, you try to now gradually understand which part of your schizophrenic is working and how they are controlling, interacting. And then you have a beautiful knowledge. We can't ignore what we learn over centuries just because there's a new knowledge. But try to understand the beauty of the interacting it and how you can benefit by it and how you mix them. The current is due to the plasmatic current. Yeah, the plasma is due. The no current is due to what you see. If you go back, the pictures you have, go very close to the left-hand side metal one. Can you concentrate? Go not to the center, to the bottom left. Who's showing this picture? We're on the showing. Yeah, go down, go down, go down. Can't go. You can't go underneath. This reactor, if you take that gray plate away on the top, they have 3 brass rings. This is the steel reactors. These are the ones. They have 3 brass rings. These brass rings are connected internally with nano copper wire into the center of the core in different depth. If you look at the Keshe Foundation pictures or keshefoundation.com or Keshe Foundation Technologies, you see those rings on this. These coppers, even though they are insulated copper rings from the steel, internally they have a nanowire. We developed these nanowires in 2005, 2006 when this core was built. And then you transfer the energy from inside out. This is what I was explaining to Arman yesterday and John, how we transfer energy inside out. Then you learn you can do it, and you can see the current. You put a brush in, you get the electric current as you are in the AC or a DC. There is no, please, you have come this long way and you start developing, understanding, testing and adding to our knowledge. But now you're mature enough to start understanding the separation. Then this question of we have no currents, but we have a light LED lit and with the voltage goes up, will not rise. But in a way it's happened, it's there. We all now know why and how. But then use this in developing new tools, new, what do you call it, materials for lighting up. You transferred, for the first time you see it, you have transferred energy without any nano layering from one position to another. This is beautiful. But now you understand how, now you understand the process. expand on it and share the knowledge freely the way you do. Then next time we go to the next step, we show the nano layers capacity. In a way, what I was trying to explain with putting nano layers and extracting energy with platforms as with Armand earlier on in this program, now you achieved it yourself without knowing it. You don't need. Do you see these are the configuration of the channels of magnetic fields? In these pictures, what you're showing. Put the pile, add the whole thing and have a look. We saw the magnetic field channels earlier on in this process, in this teaching, months ago, when we had the pile of the GANs together. Mix the magnets with the matter. You'll find out you don't get much reaction. Mix the GANs with the matter. If you get the right material GANs, you will see beautiful interactions, transfer of energies. You have achieved zero communication without you knowing it's part of the defense technology. But if you know how to use it. Any questions?
I have something. Going back to your measurement system, I would suggest using a thermometer and having the temperature as a factor there, because since yesterday's experiments, the temperature is making pretty big variations into measuring the voltages.
The voltages, we looked at the battery. They never get heated up.
Yes, but the surrounding temperature does.
Depends what you chose. This is one of the reasons we changed the reactor, which Rick just showed, the steel one. Originally, the reactors were all steel made and high temperatures and big temperature variation. And we found that there is, when you work with a plasma and a Gans state, that's why all our reactors are plastic now. If you look at the reactors in the background, just on the right-hand side of this, if you look, this reactor here on the left is a steel. If you go to the right of this picture, the white one, go to the right here, the white one, this is plastic because it's temperature independent. This reactor was built by the Iranian government in Iran. It's plastic because we realized temperature is independent. It's very low and it doesn't affect, because in the dynamic plasma condition that everything stays within what it is. It does not pay that much gain.
What Ludmil was suggesting was what we found last night when we were experimenting with Zeisen's sandwich, Gans sandwich that he put together. And he had a consistent 590 millivolts while it sat on a shelf. And then when he put it against his chest or his hands, or his arm rather, then the voltage started to increase another 10 or more millivolts. So he suggested putting it in a freezer, and sure enough, in the freezer it dropped down about 100 millivolts or so, and then came back up again when exposed to the room temperature again. We thought it might be the vibes of somebody's body, or the aura, or some, some sort of feel. But it was temperature though. It was strictly temperature dependent as far as the millivolts going up and down.
Okay, let's go back one step. What is temperature? Go back one step. How do you define a temperature? What is temperature? Well, it's a magnetic field flow. It's a radiation. It's very simple. Now you have a plasma which is depending on what kind of and how it receives the field flow in a matter environment. This is what I think it was Vince, or I think it was Vince in a couple of talks before. He says, when I put, that's how we start opening the GAN side of the technology. When I put this against my body, the voltage goes up. Yeah, when you show the first, what do you call it, nano sandwich. What is temperature? What is pressure? It's all magnetic field based. So you change the temperature. What have you changed? The speed of flow, it's more or less the speed of flow, rate of emission. What do you call it? In a given environment. That's this is now we understand gravity and magnetic field are the same base. Then you understand what we call the universal field theory. Understand what it is, explain, put a name, put the characteristics in a field, magnetic field or gravitational field, into it, and the puzzle is solved. Read the paper. It's called the Unified Field Theory. Then a lot of these things are resolved. This is part of the characteristics. This is what I explained. For example, if you look at the back reactor in the one in the behind the center one, that's the reactor of the John, and that's the reactor which we put out, and now we are looking for replacement for. John was trying. We sat down. I tried to explain to him why there is a problem with these reactors 2 days ago, because with a copper reactor we have 1 or 2 elements, mainly copper. But when I went through with John on the table, okay, tell me what are these ceramic cores are made of. He started putting, oh, this. We came to about 8-10 different elements. And then now you have a capacity, you have a cavity, and you go by the factor of the 10 elements in different composition and with the holes, then you understand why there's a problem with these reactors. You are full of different strength, gravitational, magnetic field, porosity, which is different. That's, you see it there. If you look at the white ones, the structure is not free flow. If you look at it, if you look at the part of it, it's got holes in it. So you have 10 different elements. Part of it gets oxidized in oxidization, and part of it in the process becomes nano layers. So now you have miniature capacitors, millions of them sitting in there. And at the beginning, we had a long discussion sitting in the garden with John. I said, explain to me how you make this. One afternoon, I was trying to understand the structure, how it's made. And now that we see it, they've gone through the test, is what we thought from the beginning. Different elements create different fields, they absorb different fields, and now that's why we took them out, and that reactor is not in the lab. Understand the process. Is magnetic fields, find out how this magnetic field has reached or comes to the place that affects your work. Oh, there is John building his reactor. These are historical pictures. But this is the process. Yeah, when these reactors break, when they fracture, which we had one by accident, then we saw actually it's full of holes. But when you look at the glazing, there is no hole, it's perfect. And because of the composition of the materials and the heat which is created at the time when he produces them, there are nano layers, nano pore holes are made, which they have the capability to store fields. The same thing happens with LED lights, which you see there is no current but is LED.
Those are the kinds of capacitors we should be trying to...
Yeah, well, John says, I'll give it to him.
once I start understanding that this could be the way capacitors be made for the plasma to be collected, and have a understanding of what on the one side we can produce, go through and hold them in the capacitors, and then use them to increase or lower the levels. So, well, I don't know all of it, but yet, but
How
those
about,
are
John, how about turn it directly into light? Maybe you could have a translucent ceramic that had the capacitors built in that could translate the energies, the plasma energy, directly to light. Bypass all the wiring, all the hard wiring.
Certainly that. Yes, certainly that would be one aspect, but we have to find the correct composition. And there are so many ceramics and different kinds. There are ceramics that are more, let's say, pure with only one or two elements. And you have also those that have thousands of different composition and combination of elements. So, well, we are just at the beginning of what we have to start to understand.
It will be very interesting. Something we have to do in the future. If you put aura detectors, we call it the aura detectors, around the reactors, we'll see the effect of the fields they produce. Because one of the best machines to see the plasmatic field interaction is these machines which they made to make auras. They're fantastic. Without them knowing, it can help the plasmatic condition detection very easy. And then we can put the fingerprint for it, what it is, and we see the light in a different way. Yeah, whatever it is, what it can be done. But at the moment, we're trying to process to understand a bit. This is what I keep on saying, that we have to have in this Thursday mornings, we always speak about the reactors and the processes we've done. I think we have to start going specific programs just through the theory, to understand the theory behind the plasma from the beginning. And then maybe a lot of these things for the future knowledge seekers will become much easier. It's the process. Yeah, just go back to the picture you were showing. No, the lab. You were showing a picture of the lab with the reactors in it. Yeah, just the picture. You work, open the picture up. You got to you is a picture, but to the people in high level scientific or any level of scientific research, no organization ever opens its knowledge like this to public. No one has ever done, bringing the lab, the latest, the advanced, on top of science, edge of science, so openly on the daily basis into people's life, except the foundation. Because we are not afraid of failure, we are not afraid of the knowledge we share. To you, it's just a picture in on the floor, a few reactors. But the implication of such a free sharing of energy and information and knowledge in energy, and now we do in medicine, in Gans, in nano material, has put shivers off the back of a lot of organizations. Because knowledge is free. Sharing of the knowledge is free. And so openly we put it on the internet. We don't select, this is going to go out. This is what it is, this is what we do, this is what knowledge seekers have shared from day one. And to a lot of you is just a picture in the lab, but you got to understand from huge organizations which you spend billions and millions to find a nanomaterial, and now you show them what it is, you show them ACDC, and you show them how the weight reduction is and how you produce magnetic field connections and everything else, and now the medical, the materials. The share of the knowledge, the way we done, is more important than actually the nanomaterials of the LED which has been led. Because this way now we open a new way of learning, teaching and sharing. And this is more important than anything else which mankind has ever achieved up to now, especially in past 200-300 years, with all the patents and restrictions and sharing of the information. All of you can make a little GANs and light up your rooms and things. To start making torches for the students and the laboratories and the buildings in the university using the GANs and the little electrodes from the copper wires. The same thing was shared with the people in Fukushima on Monday. And now you come up and you show it and you share it. This is what we've done, and this is how it should be. The rest is learning and understanding, and this is what we got to do, to teach more, to understand much more rapidly. The way now the Keshe Foundation Forum is set up is very easy. People who we don't mention anymore who's responsible behind the forums in the background, because then they start getting all sorts of problems. But the new people who've taken and are adding and changing the website and the forum, they're doing a fantastic job. You see now more accessible, much easier to do. What do you call it? The position which we have in it. We don't do something and hide it and don't show it. What do you call it? Marco achieved, showed the DC-AC connection literally last night, 5 o'clock, 9 o'clock, 10 o'clock this morning is on the table, and all of you around the world, you see it. You can't transfer knowledge like this so fast. If you go write a paper in 10 years' time, somebody might read it somewhere. You measure the things, you build the things, and you say this boosts the energy by from this to this volt. Can we use this? This is beautiful the way the foundation work is going. And I thank you for all of you for your openness, and those who come here to misuse or abuse, they'll disappear in time.
And thank you, Mr. Keshe, for encouraging us to be open and able to show what we're doing. I mean, that's is a big step for many people to come forward and to continue doing experiments in the spirit of inquiry and of moving forward with these things. And really appreciate all the efforts that you've done that way. And to remind people that also that the knowledge is free, but the infrastructure to bring that knowledge does cost. So I'm reminding people it'd be good to donate to the Keshe Foundation, which is there's new donate buttons at the forum. When you go to the main page at the forum, at the very top, there's a new donate button to just as a reminder. It would be good to do that in a show of appreciation toward Mr. Keshe and the Keshe Foundation and the Spaceship Institute for bringing us this knowledge that is we are so lucky to have.
The position is, if you look at the teaching of the medical last week on the live stream, I just had a quick look. Something like 2,000 downloads in a week. Doesn't matter how much they linked up to download, fed, run somewhere else. If 2,000 people for the 4 hours or 2 hour session, for what they take knowledge, contribute back into the foundation, even $1, €1, in 5 sessions, 4 sessions a month, that allows a lot of investment back into the technology. But 2,000 people, maybe about 20 people have made their contribution of, and they think just because they have to do it. This is what you take, is what you put back in. And if you think it's your right to have the knowledge free and walk away and that's it, it's okay. We are very good entertainers. Next time we do a monkey dance show on the table. But our way is to teach freely and to be able to keep the flow of the knowledge free. The whole process is understanding what we receive. We can share, go faster to achieve what the target is, to be able to create a world peace. The peace will come when we are all equal in knowledge, in wealth, and in the feeling of security. Then the next step comes, but slowly, what we see around the Keshe Foundation, the numbers runs into thousands and millions. But they were all waiting to see energy system, then they believed in it. Knowledge seekers show you the light, the torch, and everything else now is irrelevant. What's the next pole dancer on the table? This is where everything goes wrong. Where this process has to be brought back forth. We work with the scientists at the highest level, and we give them the free, totally the knowledge and the way to do it freely. And they come here and they say, oh yeah, we learned this, now we're going to go make money out of it. What's in it for us? It doesn't make any difference. At least you will change the life of some people, even if you change your own life. But the only one agreement we have, do not use and share the knowledge to harm anybody with it. The position is you don't need to kill an elephant to show Tesla is wrong. And we know who did that. The financial greed of Edison brought the life of an elephant to an end just to show that, that Tesla was wrong. Where both were right. And we don't want to go to that game.
I know you have to go here quite quickly. We're going to try to get one quick question in by Brett, who was trying to get, he wanted to have a question for close. Do we have time for that, Mr. Keshe? You have to go right now.
Yeah, I've got to be online because I teach to Africa at 12 o'clock. I've got 10 minutes to go. Yeah, carry on.
Okay, Brett, maybe you can present your question there.
Sure, it's simple. I was wondering, I was going over the math and trying to figure out the calculation for the rotational speed necessary for the reactors, and I wanted to know, is it the diameter of the physical reactor, or is it based on the fields, the size of the field that extends beyond it?
It just depends on what you put in it.
Well, say I have the standard thing. Say I have the same material and the same material the reactors are all made out of. Then, is it based on the field size outside?
No. It depends. Now with the GANs, depends on the amount of the GANs and which GANs you use. Depends on how much plasma you create if you use layering of the gases. Depends. You have to you have to make a standard for your own reactor because each reactor is different.
Okay.
We produce copper GANs from a different mine with slight different composition. You produce the GANs in a different way. So each at the moment, unless we standardize and everything will be homogeneous, each one of us is making one star in the universe and not two stars are the same. So you have to measure your own the strength of your own star and your own system.
Okay, that's all I need to know. Thank you.
Okay, thank you very much. Thanks for your help. I passed the session doesn't finish. I passed the microphone to John and Marco if they want to add, but I have to go and start my teaching on the other side. Thank you very much for your time.
Thank you,
And
Mr. Kesh.
we'll learn
Thank you
more.
very much.
Thank you.
Very much.
Thank you, Mr. Kesh.
Thank
Okay,
you.
haven't said a lot today, but are there any questions or what could I say?
And that's John, just to refresh people.
Yeah. So we've been
What can
working.
you say, John? What can you follow that up with?
Okay. In fact, this week we have been working on the more understanding of those kind of batteries, which are collectors of energy in electricity way. You saw what Armen and I have shown last week. We are going further because Armen has been working on these reactors, but with a problem of the motors. He needs new motors. There are some problems. We are, as you heard, we went to the shop and we came back with rectifiers because we needed to convert AC to DC. And that's when Kesh started saying, oh, well, you don't need that. In fact, by combining the GANs, the nano coating, and the material, you can allow, by putting in series two systems with different GANs, you could reach to a position where you will not have the AC or another system where you would have or only AC. So by making special combinations, you could push the DC or push the AC, boost the voltage or lower the voltage, and increase the current. So those are aspects we have to go in for understanding better what we are dealing with. What has been shown in some ways was the kind of conversion in an LED. I think we have a lot to do and to understand clearly what is happening. I would have a question, because the 2,000 turns of a coil made in series, that's what Lucian showed and talked about. Well, it has also a kind of resistance. So if you look at the conventional way, there is one aspect that can be analyzed, but if you go into the plasma and the plasma fields, that's something we cannot see and we cannot yet measure. So Lucian's aim was, in fact, to have a way to measure it. We haven't demonstrated that we can measure any plasma for the moment. Instead, we see what is converted into flow of electrons. And that flow of electrons is what the conventional way we are used to, because that's matter state. And we have to go into more understanding and how we can start to see and to understand the real flow of the plasma. I think that's important, and that will be the next step in what we are doing now. So what could be, let me say it as a kind of parallel with the electronics, that would be with the cell, have a resistance, have a capacitor, or some place where you will collect energy from the plasma flow into GANs material, or have a kind of way to, well, we know that the plasma, interaction of plasma can give some light, but we don't have yet the plasma, the way we can direct it, so we don't have any control yet, complete control. We have some kind of start of understanding of the control, because if we make the cells, we start to know how we have to put things together to collect some kind of energy which is in the matter state. We don't see yet what is at the plasma state, and that's the step we have to go in now.
I think we can make a small bulbs, with the nanowire and GANs, like interacting. I think when we can transfer this energy, whatever we're collecting on electrodes, to that simple bulb, nano-coated material and GANs inside. Might be it will be a huge light, which plasmatic field we can transfer to, actually light.
Yes, yes, but that is part of the understanding we need to be able to do so. We know in some ways interaction of fields will give some light. We know that in fact we are not there yet in a complete understanding of how we can do it. So, well, I would
unless we do
ask. Yes, well, we haven't done it yet. So understanding will be there when we'll have done it.
Having Carmen's soul there is going to be a very bright light.
Yep. It's a plasmatic field, You don't know, you cannot measure right now how much plasmatic fields we have in that small containers. But if we can direct the flow, we can light it up.
Well, I would not say we can.
To do.
Okay, well.
Go ahead, John.
We'll have interaction of flow, and then we'll have the light. It's not lighting up like we have the habit of switching a light on, because it will happen in another way. But anyway, let's go on.
I'd just like to say about the measurements. If you have here a mixture of DC and AC, now our usual multimeters have milliampere or microampere scales only for DC, not for AC. If somebody has a special instrument to measure AC that also has a limit of frequency, from which frequency to which frequency can measure. So oscilloscope can give some information about is there such a current on a high frequency or AC on the wire. I was wondering about Lucian's affirmation that he cannot measure current on that AC circuit. Of course, LED will light on AC. It rectifies the positive pulses, but yet without a proper instrument, you cannot measure that. So it's very tricky. So there are different ways how to measure that energy. One of the ways is, for instance, if you can produce a current which can heat up a resistor, a resistance, in that case to measure the temperature difference. And there are some other tricky things, but anyway, it's not so easy. And one of the ways would be to see if you get out energy, not just voltage, but energy energy which is calculated by a product between voltage and current. In that case, for instance, using a small such a Christmas tree light, you can see if it's lighting only a little, or it's lighting a bit stronger. So we have to go back to the past beginnings of past centuries techniques which were used for making measurements. So our digital instruments are not suitable for such kind of measurements. So there is a lot to think about and to develop. So development will need such instruments to see what happens in the invisible part of the world, but it's very tricky how to do it. So that's a very interesting subject.
One of the first instruments would be just a neon lamp that could be waved around with high voltage fields and so on. It would light up. So again, light might be an interactive way to judge what plasmatic fields are happening. Different types of gases would interact with the fields depending on the frequency or vibration, perhaps.
Okay. Actually, an LED shows that there is a current, so that is a kind of instrument. It's a higher current, it's a higher light, it's a brighter light. It's a smaller current, it's a smaller one, but that also will have an influence of the voltage. So it's a very complex thing. It's not so easy. Sorry, maybe Lucien had something to say.
Yes, I would add to what has been
we have
said.
A very rough
Okay.
Okay, let me
just
tell something.
Yes, go on, Lucien.
Okay, just a second. Sandor, we have a very rough calculation. It is a capacitor of 130K. I don't know what is in that, in picofarads or something like that. It's taking about 6 seconds to charge. And when it's charged, it's giving about 6 volts, and the LED is blinking maybe, let's say, 0.2 seconds. So roughly we can find out what kind of energy is there. That means 1 point something volts multiplied by 20 milliamps and divided by 0.2, or is a couple of 0 point something milliwatts. Okay, go ahead, John.
Okay, I'll just, you talked about picofarad. Picofarad, you need a very high voltage to have some energy. It's not the voltage of a LED that would give you, not even, it would be near the macrowatt or even lower if you have only a few picofarad. So it might be microfarad, which is a much bigger, much, well, it's
written 130K. I will check for you how these guys are marking the capacitors.
130K.
Yes.
It's a strange notation. I'm not used to that kind of notation. You could have 103K, 103 or something like that. But well, it does not conventional notation.
So I will check the catalog for you.
Yes, but usually it's microfarad, or there are special figures and numbers that are used. So, okay, that was one point. Another point, and Sandor said what energy in the system I showed last week, last workshop. I showed that I could have LED lit, that I could even have 2 LEDs lit because of the way I made the 2 circuits which were in sort of parallel way, but using each cell as a double way of collecting energy. One thing I missed in my explanation, in some ways I inverted when it was AC or DC. I said the other way around. Apparently, when I start to listening to what I said, it was inverted. This is one aspect that I wanted to correct. And in fact, there is another thing which is linked to that. I would have been very happy to have an oscilloscope to see what we are having. In fact, we are converting the plasma into packs of energy, level of the electron. We are collecting electron and positron maybe, both in that conversion. And in fact, when you say AC, we measure with a digital multimeter some AC. Don't forget, when you use a standard DC 9-volt battery and you connect to it, at the moment you connect, you see as if there was some AC. In fact, that's the way you are putting a step in the measurement, and a step is, if you make a Fourier transform of a step, it's a collection of frequencies. For me, the AC we collect might be white noise. If those who made electronics knows what is white noise, it's a full spectrum of frequencies without any specific frequency coming out, but the whole lot of frequencies being there. And oh, nice! I see a picture, a drawing of what I have been making there. Apparently, seems to be nicely done. Whose drawing is it? I don't know. Oh, no, maybe later. So that
John,
was an aspect
to interrupt you just a second.
That was Sandor's drawing, actually. He wanted to. I think he sent you a copy to see if you could confirm that was what you meant by your circuit, basically. The one that was in Facebook didn't have the ends connected, so Sandor wanted to make sure that the complete circuit was shown.
Yes, it seems to be that. I cannot see the details because of the picture I have in front of me. I see on the bottom side. In fact, I had kind of ball nano-coated with the nano-coating going outside. And around that nano-coating, which was outside the system, I've been winding some wire, which is a solder wire, because it's easy to wind. And the tip of that nano-coated wire has been uncoated by scratching. And there I have made a soldering to the zinc that was in the next cell, and the solder wire going around the nano-coating was also going into the next cell. So that's perfectly what I have been doing. the thing is that I've put rectifiers on both connections and showed that it was giving some light immediately without even collecting that energy. It was putting out some electrical energy enough to have my LEDs lit. What I've made after that, and it has not been shown, my system has been kept, but Mr. Cash has that system, and I haven't got it back for the moment. But the system, I've been adding some capacitors, and by doing that, I allow the system to collect some energy, and thereafter I could have a fan working. So the fan was turning for a few seconds. If I did put battery and let it charge longer, well, the fan would have worked longer. I was at about around 7 volts, and the fan was one of the small fans for computers. Well, it's how much? 10 centimeter fan, just about, and it was rated to 12 volts. Those fans has an electronic inside, and usually that electronic is what is allowing the rotation because of kind of step motor that is inside. So I was collecting some energy that way in the capacitors, and I could have some light on one side, and the other side was charging my battery of capacitors, 4 capacitors of 10,000 microfarad. It's not a super capacitor, but it's already a capacitor which allowed to have enough energy for a few seconds of the fan. So these are points I wanted to get out, and we have to go on all those understanding, putting the plasma at a high level, lower level. What was interesting also was to see that we need a gradient of the energy, and that gradient is what allows the flow. So if we have a gradient of potential, we have a flow of electron. If we have a gradient of plasmatic magnetic fields, we'll have a flow of plasma. And the way that flow will go, that's what we have to start understanding. Okay, anyone has to add anything to that or ask questions?
Probably should start wrapping things up, I guess, for the live stream here.
Yeah. Okay.
Is there any other questions that people have to ask at this point, or have we enough to go on for a while?
I have a question.
So, John, just a very quick question. Your 7 cells that you showed, how much voltage did you have there? Like 5-6 volts or what?
7 cells? No, I had a little more than 7 cells.
Or 6, I don't know.
Each cell is around 800 millivolts, 900 millivolts. Some of them they give 1 volt. So this is the things that we got.
Thank you, Arman.
Those are Armans. They are Armans. We've been building two separate and two different. One small aspect I should add for the cell I did, and the picture that is shown by Sandor, I had a very little quantity of GANs and more water on the top. In fact, the systems should be completely immersed in GANs. And so that's why with a small volume that we have the electrodes that are completely in the GANs. Yes, no. Because as Marco saying that we'll always have water. We do need water, but we need to be in the GANs itself, and not as I did, having the coated electrode above the GANs, only in the water part. So that's something that has to be understood, and that's why the voltage I was collecting was lower than if we are in the GANs. Because GANs is, let's say, heavier, it's denser than the early water, and that that water is in the field of the GANs, but it's not the GANs itself directly. So it should be, those electrodes should be down.
So in other words, the phases do not have to separate; they have to be mixed.
The nanomaterial has to be in GANs. What I saw, because I was in the water, was a kind of formation of GANs around the nano-coated electrode, because I was in the water. So I did have some lowering of the voltage, but when I shake it, allowing that formation of material around the electrode, then I had again the voltage from the beginning, which was around 500 or so millivolts per cell.
Right, thank you. I have about 700 millivolts, so we are in the same, more or less in the same range.
Yes, it depends. It depends a lot on what kind of material you use as an electrode. Don't forget the first electrode which is coated is copper. Copper was nano-copper material on the surface, nano-copper oxide. And the liquid is pure water with some GANs in it. In fact, we should have only the GANs with a little water, not lots of water, and a little GANs. So we need to be in another position at that level. The conditions are very important for that. And the second electrode is zinc. I finally had zinc from Armin. He had a sheet of zinc, and I've been cutting it to have thin electrodes. And the third electrode is the soldering Y, which is 60% lead, 40% tin. So with that combination, I managed to have voltage, and might be less voltage with the tin and lead than on the other side. It was about half with the tin lead electrodes than what I had with zinc electrodes. And don't forget the tin lead is around the copper with the nano coating, so it's insulated that side. And zinc is soldered to the copper inside the nano coating. So, hope I've been clear enough for understanding of what I did.
Yeah, I think we'll have to draw a new picture of all
Yeah.
that, but thank you for clarifying. That helps a lot.
So,
And container size does not matter. So you can make it as small as you want.
yes, but you have to be in the GANS material.
Your containers are big. You know.
Yeah.
Even in our small containers, we see that we have to drain a lot of water from GANs.
Unless we have a huge production of GANs, it's better to have smaller containers.
We're done with those. Sorry. Yeah, so I think it's time for us to end it. We have to get shut off for the live stream before 4 hours comes up here, or else it turns into a pumpkin. Is there anything else that we need to add, or announcements or anything before we wrap things up here?
No, thank you all.
I do have the health workshop coming up tomorrow. That is Friday morning, 5 a.m. Pacific time, or was it 2 in the afternoon?
Yes, 2 in the afternoon.
2 in the afternoon Italian time. Central European time, that is.
But normally Elia should give the confirmation of the session. But
yeah,
normally it should be.
Right, she's ready for it apparently, so it should all go ahead at that time so far as we know. But we'll make another announcement in the live stream as well. Or, sorry, in the Facebook and the live stream, actually. Okay, well, thank you, everybody, for...
and the forums.
And the forums, yes. Let's not forget about the forums, the new revamped forums, as it's getting fixed up.
Yeah, it's already working, Rick?
Yeah, it's working fairly well right now, and we got some more improvements happening, and hoping people will start to use it more and more. And Mr. Kesh is looking forward to using it more and more as well. So we hope to get it reinvigorated with some new energy there. And don't forget the donate buttons don't forget the donate buttons at the top of the page. Go ahead, Vince.
Sorry, I would just like to add, because there was so many problems in the past with registration and getting onto the site and posting. If you are part of the forums and you are having those problems, just try re-registering or trying the contact us button at the bottom of the forums, and we'll see if we can get it straightened out.
Yeah, thanks, Vince. So, okay, well, that wraps up.
And don't use the PayPal if you can help it, but you can still donate through PayPal. It's just preferred to donate directly to the bank at the moment.
Right.
Which is under the link on the forums.
That's right. At the top of the forum, there's a link for the donation bar, and you can find all the information on the bank in Holland for the Kesh Foundation, and make a direct bank donation there. Okay, so I should wrap it up, I guess. Thanks, everybody, and thank you from the people of the Spaceship Institute and all the folks on the go-to meeting and the live stream. Sorry about the problems with the live stream initially, and we'll try to get that sorted out for next time.
Thank you, everyone, for participating and putting your understanding.
Thank you. Bye-bye.
Okay, thank you, everybody. Have a good day.
Okay, bye, everybody.